So tonight we're covering classes, as I mentioned, which is chapter 10 in the book. I don't really care for the cannonball example at this point. I think it's more complicated than we need to have it. And so I have included a different example with the shape, which is a very common use of making a class. So we're going to start with an example. And I think there are a lot of concepts we need to cover, but I feel like the best thing we can do is actually let's code a program using a class that is defined by us, and then see how it works, and then we're going to go back and look at the concepts. Now, the question I have for you is, have we used classes so far in our class? For example, John?
Like circle and line and all those graphics on here.
Right, so we are actually very familiar with using classes. The one thing we haven't done is define our own, and tonight we're going to learn how our own classes are defined, and it might be fun to go and open the graphics now with a fresh eye and see the definitions of the classes there, and see how the process is the same. All right. So please open up your idle editor. We're going to running that uses a class to create a shape, and I will explain what we're doing, and again go back and cover all the concepts as well. Magnifying. Where are you? Okay, so save your file as shape.py. Yes. Oh, thank you. Let me try this again. All right, well, I do have to do just a little bit of talking before we start coding. So the goal of the shape program is going to be to create a shape where you can pass, let's say we want to have a rectangle and you pass it the width and the height, and then it can calculate, for example, the area. And so it might seem like what we could do is, why don't we just use a function? Do you think a function would work?
Yeah.
A function would work to a certain extent, but the problem we face is that with functions, we actually don't preserve the variable information. We can do calculations, we can accomplish tasks, but we don't have a way to essentially persist the value of the variables inside our program. And the class is a unit that organizes our code in such a way that we can persist and save and use both variables and functions in the same package. And I'm using the package not in terms of a Python package, but just a package of in terms of organization. And so that's what we're going to do here. And then we're going to learn step by step how this is accomplished in Python. So this is going to be, I'll just have a comment here, first class that we are defining ourselves.
Oh, we need to turn that.
Okay. So when you define a class, you have to give it the keyword class, and then you have to give your class a name. In our case, the class we're defining is going to have to do with the shape. So classes are one component of a program where you actually capitalize the names. So in this case, we have a capitalized shape, and then colon, and then the indentation is going to show what belongs to the class. So the class in general is going to always contain two different things. It's going to contain data and it's going to be able to do things. And so for data, what do we use for data? variables. And do we know what to use for accomplishing tasks? Functions. So we're going to have special variables and special functions that belong to the class. And we call the type of variables instance variables. The type of function, if it belongs to a class, we're going to call it a method. All right? And the first method that the class has is a special method that is called a constructor. And for now, let's write up the definition of the constructor. And you use the following syntax: def double init, and then self, x, y, and description. So, where's my pointer? So this method, so this is the definition function, the special function called a constructor, and the syntax requires you to use the underscore in it. But what it does is, when you create a class, this method actually instantiates, makes instances of the class, okay? And we call it a constructor. And in the constructor, what we are passing are any variables, any parameters that are going to be part of the class. We need to pass them into the constructor. So in our case, with the shape, we're going to have just a description to say our shape is a rectangle, some simple string, and we want to do a calculation of the area. So what do we need for that? We need a width and height, which we can describe as x and y here. And in a Python constructor, the first argument that is passed is always the self. So you pass the object. So self will always be the first argument that gets passed to any of the functions, and this is just the rule of the language, okay? So right now we have written the signature of the constructor. And then inside the constructor, what we're going to do is we're going to set the instance variables, and the way you describe this is self.x is equal to x, and then self.y is equal to y, and self.description is equal to description. So what is happening here? What is happening here is that we, at some point, we're going to pass the width, the height, and the description to the class, right? And then when we do, we're going to set the instance variables. The instance variables are, the syntax for them is self.x, so that they're not confused with the x, which is the argument, right? So those are two different things. Self.x refers to the instance variable of the class, whereas x refers to the parameter you're going to pass into set. So for example, when we pass the width is 25, then the self.x will be set to 25. And just bear with me when we write the program and run it. Hopefully it will become more clear if it's not already. But we just defined the constructor of the shape class. And this was our first step. Now we want our constructor to accomplish certain functionality, and the first one is to calculate the area. So we need to write a function for calculating the area. And we're going to define our function. These are all part of the class. And we're going to give it the name area. And we always, when we are defining functions of a class, have to pass the self. So the area is calculated by multiplying the width of the height. And therefore, we can say return self.x times self.y. So we now have stored our instance variables now are storing values, And then we're going to use those values to multiply and return the area of the shape. Our shape can also calculate the perimeter. So again, when you're defining the function in the class, you always have to pass it the self. And so what is the perimeter equal to? Well, it's 2 times self.x times self.y, right? This is just elementary geometry there. And how do we know what functions go in the class? How do I know what function should go here? Well, it turns out you have to come up with the functions that make sense. If you're designing a class for shape, then you have to decide what makes sense for a shape, what functions are supported for a shape. If you're designing a class for a vehicle, then you have to decide what makes sense for a vehicle class in terms of functions. You know, it's going to accelerate, it's going to stop, and so on, right? But the reason those are the functions I'm using is because I designed the class and I decided this is what I want to use. Does that make sense? Actually, I modified it from somewhere else because that's a very common example. But the point being is that you have to come up with your own class methods. If you're, as in your homework to define a class, you need to come up with your own for your class subject that you choose. All right, I gave you a very easy homework this time, being Thanksgiving and all. Your homework is to essentially just define your own class and then create a couple of instances of it. So we're going to go through the steps tonight, and you just have to apply it to a topic of interest. Right? And we'll talk more about it. What are appropriate subjects for making into a class? All right. So my class is going to also support another function, which is called scale size. And this is going to allow it to take the scale and bring it up or down. So again, as always, I have to pass the self and then the scale. Self.x is going to equal to self.x times scale. And self.y is going to equal to self.y times scale. So again, the self.x and y refer to the instance variables. Is anyone wondering why is scale not an instance variable? Or why do you think it's not? Any thoughts? Not yet? All right. So the reason scale is not an instance variable is because we only need to use it inside this function. The class actually doesn't need to preserve the information about scale. And if this is the case, it would be not a good use of our resources to define the scale instance variable. All right, so now we have 3 methods, and then we're going to add a 4th one, which is called set description. Notice that I'm using the camel case when I have 2 words, right? Do you remember the camel case? We've talked about it. All right, so make sure to use it. And again, what is the first argument I'm going to pass here? Self. And the second is going to be the description. And this is what we call a setter method, where we're going to get a value and then set the instance variable directly. So if I wanted to set the description, I will use set description and then say self dot description is equal to description. Actually, I think if we're calling it directly like that, we need to use an underscore under here. So you add an underscore. And these are the classes, the functions inside our class. So that's what our class can do. We finished with creating the class. And now, when you start thinking about the class, the most helpful, one of the helpful ways to think about it is a blueprint. So this is a template or a blueprint out of which you can create instances of specific shapes, but that's not something specific in itself. Does this make sense? All right. So it's a blueprint. And we have a blueprint here where we can now creating what we call specific instances of objects. So you could call this from the main, but for this example, we're just going to call it directly from here. And so how do you create an instance of an object? So let's create an instance of an object. And note that this is no longer part of the class definition, so you need to indent it to the left. Okay. So I'm going to create a variable rectangle, which is going to be equal to the name of my class, which is shape, the same way as we used before, a circle, point, and so on. And then I need to pass it 3 arguments. And when you're creating an instance, you no longer pass the self, so you don't have to do this at this point. But I need to pass it a couple of values. I need to pass the x, the y, and the description, such as rect. So now I have created an instance of a shape called rectangle. And that's how you create objects. And when Python interprets the line where rectangle equals shape, behind the scenes it's going to call the constructor method, and then this is what actually creates the object. So now that we have created an instance of an object, what we get to do is we get to use the methods that belong to the object. So we can now say find the area of the rectangle. And to do so, we're going to call rectangle.area. And this is the line where you call your object by its name, right? And then you call the name of the method. So in this case, the method is area, and it doesn't take any arguments here. So we just call create area, right? But we want to print this out so we can see what it's doing. And therefore, we're going to say print area, rectangle area. Looks like it's break time.
Stop this again.
All right.
We need one more.
Let's see one more print here. All right, let's add the line for the parameter as well, and then we will take a break and then finish it after break because we need to stop and talk about everything. But just 1 minute. The next one is find the perimeter of the rectangle. And so this would look similarly. We're going to print perimeter, and then rectangle dot perimeter, which also doesn't take any arguments because it's going to use the instance variables. Right? So finish this up. Let's take our first break. And then we finish the program, and then F5 to make sure that it runs and it does what it should do. And a 10-minute break, please.
Thank you. I'm gonna go home and I'll watch it. Yeah.
Plus, I think it's this Thursday, so it's like I already got to do that.
I had to do that last week where I missed the previous side. Classes in one day. It was like,
No, I did the calendar myself.
everyone did the calendar.
We did the light bulb.
So yeah, part of it, the miss is the calendar part. You didn't get to it, so we had to watch the video on your own and do it.
I was there for that.
Oh, really?
That was on Tuesday.
I think I'll-
Thursday was a light bulb.
Yeah,
Pretty much cut and paste a bunch of stuff.
pretty much. And that's the same with calendar. So if you know how to go to Google and create a calendar, make the calendar public, and then go and grab the iframe. Exactly.
And a bunch of cutting.
That's all you're doing.
Yeah, the cutting part of the thing. Be good.
Yeah, I did my calendar this morning. It was,
Good thing I didn't argue that. I thought it was due on Thursday, so I did everything.
what?
The-
Oh, responsive design.
Yeah.
I thought it was done today. Okay, yeah. I did that. Is that, oh, great. The wire plug. And that whole presentation. That's due on Thursday. Like, yeah. Like, can you like change the date? I enjoy when I get things shooting. It's okay. Well, I have Bill from my other class. We did the site that we posted on Saturday that we do that file that Sunday. Well, I checked my yeah, and what? Yeah, and I have to provide some business. My client is me, so I'll be pretty agreeable.
Can you take a picture? Sure.
At least when you play players. Yeah. One thing that I learned when I did web design is that you just create an empty image. Yeah.
Taking those notes, Sue. You gotta take those notes.
Oh, that's not hard.
Yeah.
Basically, it's
Sorry I didn't get to it sooner. I feel bad about that.
It's bad. I fixed that. Then I had it. I said, you just give me a 2 9
Well, I was gonna do it for
Get so much.
Unity
much
Museum,
life.
so
It takes me 2 seconds. Don't worry about it.
And I offered.
No, what I write is since I'm typing so slow when people, I saw people writing that much. I said, oh, this,
I mean,
I spend
Saturday
all
there,
day
I
doing
saw
nothing
that.
but writing emails and making reports.
And that was
Yeah, I mean, it's nothing. So don't worry about it.
What track are you
I
on?
didn't have a chance
Well, I'm
to
on
say
web
it
dev
was-
now. I was on web design. We had our class
Okay.
together.
No.
And I'm really disappointed
how
that
it
like the web
was.
development course for night students is just a mess.
Oh, yeah?
Like web design, I was taking 3 to 4 classes every single quarter because they were all well scheduled and stuff.
Oh, okay.
And 2 quarters in a row now for web dev, I've had like 2 or 3 classes I need to take at the same time.
Oh, yeah.
Like they're
I
both
ran
like
into
when,
this just now.
yeah, like I mean the one class I can send up to 2 classes next quarter. Stani's Java or the Newman's ITC 240.
Oh my god, I'm in the same boat.
Right,
Yeah.
and ITC 240, we need to take it
Yeah.
because it's one of 3. And so like we need to take it like as soon as possible. So I'm in the waiting list to try to get in
Yeah.
there.
So that's Newman, right?
That's new.
Because I think that they do they tape it. I mean, they record it. I'm
Yeah,
gonna
they
ask
usually
today,
record.
so
yeah.
maybe. But are we able to register even though they fall on the same time? Because I mean,
No, the system won't let you. If you sign up for, I signed up for Stani's Java class, and then I couldn't get in the waiting list for ITC 240 because it said you're already registered for another class at the same time. So I booked out Stani's Java class because I can take that later.
yeah,
Like I have a feeling that's probably offered every quarter.
yeah,
But ICT 240 I need to do right now because there's 2 more
Yeah.
classes after it.
Oh,
So I might not have any classes next quarter
yeah,
just because I'm waiting for that one.
exactly.
basically.
Web design, I was taking one quarter I had 2 classes. I was taking like 4 and 3 classes.
Have you thought about doing programming, like the programming track?
Oh, I super enjoy it. Yeah,
Yeah,
I like the design stuff a lot,
Yeah.
but I have a feeling that I am going to be able to teach myself the design stuff now that I have a good language for it. And stuff.
yeah,
But this stuff I need like someone to help me with.
yeah, yeah.
And I took the you know what it was in web design. We take a database planning class, database design.
Oh yeah, didn't we take it together? No.
No.
The-
I don't
Okay, I
think so.
took that
Did
one
you
last
take that
quarter.
with okay,
No.
I took it 2 quarters.
Oh yeah.
There's different ones.
Oh my, did you take it with
Okay.
Hansel? Hansel on?
Yes,
No.
right
Okay.
next to the-
I took it with Hansel. He's from like
Another
Microsoft and stuff.
building.
Okay.
And he told us like his version of the class is pretty tough.
Always building stuff.
And I liked all it was just abstract planning of databases.
Yeah.
And like it wasn't until literally the last 2 or 3 weeks that we loaded up SQL and like punched in SQL.
Oh yeah, it was the same for me.
Right.
For
And I
the-
really liked it. And that's when I was like, oh, I could feasibly do this. Like I
Yeah.
like development a lot. Like I want to do more
Thanks
things.
to the-
Were you
But then the
doing a
design
lot
stuff-
of like the requirements and all that, like for your client or something, or was it different? Because for mine it was like we were working towards, I guess, building the database for someone's business,
Sure. Yeah.
and so we were doing all this weird stuff at the beginning where we needed to work the requirements, like how
Yeah,
do you ask
yeah.
for this and that.
Because when you're making a database, you have to like plan on like,
Right.
who are the stakeholders, what do they want.
Right. So you
like,
did that too.
Oh yeah.
Oh,
yeah,
okay,
yeah.
okay.
It
And
was-
at the end is
it
when
was
you
very
were
cool.
building it on Visio and all that.
Yeah, we did a little bit of that.
Okay.
We learned a lot more theoretical, like a lot more abstract stuff.
Okay.
Because what he said was he wanted his students to be able to answer the questions in Microsoft correctly that they
Okay.
would ask you,
Okay.
and have you honestly
Okay.
understand the answers to the really high level
Yeah.
stuff.
Okay.
And then at the end, we finally got into the database stuff.
Okay.
So that was a lot of fun. But
Yeah.
when I took that class, I was like, I'm switching.
Yeah.
Like,
I wish I had learned the one that you and I took together. That
Linux?
class. Yeah.
We didn't learn shit about Linux.
I know. So I was telling you that I wish we had learned more because actually a lot of the jobs they only work on the console. Like that's all they do. And I'm like, I didn't learn that.
That was a great class. That was an excellent class.
Yeah. I just wish I had learned more. Yeah.
I
Yeah.
have a feeling that's.
Yeah.
All right.
I get Becky Boy's song stuck in my head. Good. It's a good one.
Oh, it's so good.
I didn't listen to the album. All right, let's finish our program here. All right. Now we also have. This one, right. We also have another function here. We defined which was the set scale. So let's call it now. We're going to call it rectangle dot set. Scales. What do we call it? Scale size. And here we pass it the scale, so we'll scale it down to 50%.
Rectangle has an extra T.
We have capital S.
Oh, yeah.
Thank you. Oh, okay, another type of here as well. See. Okay, so far, what do we have? Do this again on a clean slate.
Nice.
So my number is incorrect. Do you see the problem here? That doesn't look right, but I can see what the problem is and I can go fix it. We need to have 2 times x plus 2 times
Alright.
y. So this number didn't add up, and that's also okay. That's why we test. This looks more what I would expect. All right. First of all, is this working for everyone? Are you able to get it out?
That works.
Is there an issue? Okay, good. And by the way, for now, the line scale size, I should not have even added it here. Essentially, that's where we stop for now, and then we're going to change the scale size and then print again to see how the result changes. But let's take a look at some maybe syntax errors we encounter. I'm sorry, but I don't know. Chris, scale size, it's not 0 point, oh, like 0 point. Like scaling down 50%. Again, if it's easier for you, you can look at the video. But there we go. All right. So can you does it make sense what's happening?
Okay.
I'm
getting an error. But it's a primary. Oh,
all right,
So
so
preliminary.
this was the very basic example of actually creating a class, instantiating a class, and then calling a couple methods of the class. So this is the heart of
comma there.
working with classes and objects.
No,
and
just
the
like
most
the
simple
error.
way I
All,
can think
so
of.
all functions are object dot
And the
function.
steps again, we have to
So
define
the
our
model
class.
that
This is
Yeah.
like the template
Just
or
like
the
rectangle
blueprint.
here, yeah.
Oh, okay.
The class is going to have instance variables and methods. It will always have a constructor. And then once we have defined the class, we can create an instance of an object. And the other thing that's powerful about the class is that we can create multiple instances, not just one. So far we have one, but we could actually create as many as we need to. In fact, sometimes it's referred to as a factory. So it's a factory for, stamping out or creating objects. And so with our object rectangle, we called the area and perimeter method, and we got our results. All right. Any questions? All right. This is a pretty important program to make sure to understand, because you will encounter object-oriented programming in I think most of the classes should be taken, like PHP, Java certainly, and then this will help you to navigate. The syntax will be different, some of the rules will be different, but the object-oriented principles are the same. Yeah.
But I didn't understand the first time you explained what self-x equals x and self-y.
Okay, that's a good question. So what we're doing is we are setting the self-x and the self-y. They refer to the instance variables. So those are the special variables that belong to the class. And when you first start the program, they're not set to anything, right? But you want to set them to some values. And you set them to the values by passing the values as arguments. And so then we're going to set them to 145. Do you see the correspondence here where we create a shape object? We have 3 arguments we're passing. They correspond to the X, Y in description. The cell gets passed, but it doesn't get called when you're creating an instance. It only gets specified when you define a class. So that's where they come from. So essentially we set up our instance variables to equal 100. So x is 100, y is 45, and description at this point is correct. And then we get to use these because they're part of the class. And then we get to manipulate them and calculate them. All right, that was actually a good question. All right, and then the next thing we did here is use called the scale size method. And this method is going to take the amount of the number that is stored in the cell of x and y and then scale it. In this case, we're going to scale it down by 50%. So now, after we did that, because it's a class, the variables are going to be updated. They're actually going to save the information that we updated here. And after we created after we did the scale, let's try calling it again and see the result if it changes. So we're going to now reprint the new area of the rectangle. We print scaled down area. And we call the method again rectangle.area. So let's try this again.
This is the scale, self-scale function. You just need
And you can see the difference here. And if you do the math, you'll see that it scales down x and y by 50% and then provides this, calculates the area with the new values now, which are scaled down 50%. Right? So we're still working with the same object, but we changed the values of the instance variables by reducing them by 50%. With the last 3 lines here. So let's make sure this works for you as well. And do ask any questions you have, please. Normally it seems that students who encounter object-oriented for the first time have a learning curve, so it's perfectly okay if you want, have questions. Questions? All right. Okay, so then the next thing we're going to do is let's also set the description of our shape. And so remember, we have a set description method, and we can call rectangle dot set description is equal to, and it's a string, so rectangle shape. It's awesome. So right now, before we set the description, the rectangle was set to RECT, and now we're going to change it. And after we change it, we're going to print rectangle.description. So we're calling the instance variable directly here. Normally, if you want to manipulate an instance, oh, I didn't set it. Hang on, let's see here. Hang on. Spell anything?
Oh, you're setting it like a variable. It needs to be a function.
Oh, there you go.
Yeah, I didn't
This
see
is
that.
exactly right. So now,
No, I'm still into it.
oh, because we actually pass it as a, we don't set it pre-call. I think that's what we need to do here. I wonder how I got this to work over here.
Yeah, good stuff.
A couple things. There you go. All right. So a couple issues here. When you're calling self description, there was an underscore that needed to be removed. And then after that, you call the set description is a function, so we have to pass it the parameter as an argument. And then the last thing we're going to do with this example will be to show how we can create a couple additional instances of the object. Create two more instances of the shape object. Are you clear what we mean when we say instances of an object? So for example, we're going to work with a student example. Let's say we have a template for what the student information has to be in our classroom. We need to have the student name, ID, address, and so on. And then that's our class template. But then I can create an object for each of you and then populate with your particular data. So that's what we mean by an instance of an object. So John can be an instance, Geneva can be an instance, and on and on and on, Michelle, and so forth, okay? And that's what we mean by instances of objects. And so if I wanted to create more instances of the rectangle object, I can create, I have to give it a different name. So long underscore rectangle is equal to shape, and I can pass it different values. Now this object is going to hold the same characteristics as a shape class, except that the data is going to be, the instance variables stored for it will hold different values, right? And that's why, that's one of the reasons why classes and objects are so powerful. So I can create as many shapes as I need and want to, right? Or as many rectangles with different dimensions as I want to. In this case, we only created 2, but you can create additional as well. Would you like to try to print out, calculate the area for the long rectangle? Let's give it a try and see if you can do this without me. So again, with the long rectangle, calculate you can change and do essentially the same. But at the very least, calculate the new updated area. And when you're printing it, maybe you can add a line saying this is the long rectangle area so that you can see the difference between the two, right? So what do we look on?
I definitely sign myself out at that time and try to put it down.
Okay, but do you need, what do you need on canvas?
Need a pass to see that at the same time. Yeah. I can't see anything from here. Well,
Okay, this one is not in the book, so yeah. Okay, so we can go to modules. Okay. There is a file.
one else.
Okay, so let's open this file. And this is the file we look at. Except I'm asking you to add on to it, so after you do all this, then you need to add. Calculate the area for the long rectangle. What do you do? I like to know the name of the class factor. I don't know if I change that. And then when you create the instance, you have to change the date to get it. You're missing another score to be moved. Yeah, so you need to have your class to be the same. So the class will be exactly the same.
Okay, so everything else.
And then you're just going to create a
So what do
new
we
shape with a
So
different name.
go down.
Instead of
All
called
we're doing is
rectangle,
we're
we
making,
call it
we've made a new
long rectangle.
long rectangle
So
variable
Oh.
object.
You need
So
the
now
class,
print
yes,
the
that's right.
area
You
of
use
that
again. Yes, Geneva?
new object
Of long.
for long rectangle, yes.
Oh.
Yeah.
Okay, cool.
Mhm.
Okay, thank you.
rather than which I have up here, rather than what I have here in the same description. So since it's good for
that fine. It's gonna be fine. Remove the single square. Is this working for everyone? Were you able to get it to work, more or less?
Should I just make sure
Equal x, right? So initially I have to gain some x here. Is it possible to multiple x?
No, because they're different. The x is referring to the arguments. If you want to refer to the instance variable, the rule of the languages you get from itself within the class. So you must use that. All right, any other questions? All right, let's look at some lecture slides and try to explain this differently. And if we have time, I do have another example from the book. I thought the best example has to do actually with the student class. But if we don't finish tonight, we'll continue with this topic next time we meet. But I do feel that you have enough to start doing homework. So I don't think, yes, Jennifer?
On the homework, it says to pick a subject, so
Yes.
be any kind of subject?
So let's talk about what subject makes sense. Does every subject make sense to be a class? Probably not. So let's actually, before we look at the slides, let's throw out some ideas of what might be a good class and then instances. So who would like to start? Could we have a cat class? Yeah. All right, so if we have a cat class, you know what there is? I thought we already did a
Yeah,
cat
we did
class.
kittens,
Yeah,
I think.
all right.
Beginning.
If we have a cat class, would this be a good candidate for making it into a class?
Yeah.
Yes. Why? Because the cat has information and it does things. So it stores data, it has data and it does things. It's going to have a name, a breed, an age at the very least. And then it does things such as, meowing and, eating and being cute and so forth. And so this is one example where a class would be good to calculate, to use rather. Any other examples?
Dice?
You can try dice. There is an example in the book, but if you want to try one of your own, that would be great. That's great, because it has properties and methods again. All right, anything else? Students love music CDs and books and things like that. I believe that part of the requirement was that you have to have one of your methods, you need to pass the arguments to calculate something. So just make it work. If it's, for example, if it's a CD, then maybe you can calculate if the price of the CD is X, then you can do you get a 10% discount. So you can have a get discount method, for example. But I want to hear a couple more class examples that might interest you. What else? Chris.
I'm still a little fuzzy on this one, honestly.
All right, and Brian. Any ideas?
Sure, car.
A car is like a classic, pretty much example of vehicle. All right, so could you tell us how would you design a class for a car?
The color, get model,
Okay,
speed.
Yep.
Left, right, brake,
all right.
stop.
So, okay,
Yeah.
so very good. So what Brian said was one other thing to help you maybe orient yourself. The variables are going to be defined nouns. So Brian said color and speed, those are nouns. So we know that that's a clue that those should be represented as instance variables. Whereas speed, you said, or drive, or you said a verb.
Right, left, because of actions.
So go left or go
Yeah.
right. Those are verbs,
Mhm.
and that means there will be methods. Now, obviously, Brian is not going to write some, Android car thing to turn left to right. So if that's the kind of methods you have, then you can just print and say, go left, and then you print a line, go left. And this, at least when you call the method, we can see it producing, doing what it's supposed to do, even if it's just a line. So a car is a great one. Let's do two more.
I have a question about the cat one.
Sure.
What sort of function would you or methods would you use in that case?
Right. So, like I said, you can do the cat eats, sleeps, and purr. And what can you do? You can, print out eat, sleep, or purr. Maybe you can pass for the eat an argument that is the type of food it likes. Like it's like
Okay.
turkey or fish, or
Okay.
you can design it a little bit like that.
Okay.
But this would be the examples. Play maybe.
Okay. I guess I have a little hard time or understanding because for shape it's easier because you can imagine the area or you can imagine this and that because you
Sure.
have a formula too.
Right.
So for living things or even cars, for example, you would for speed, for example, we would need to input somehow the formula for speed, right? Or
Well, the requirement is to just create the method and call it, and you can just print out.
okay,
I mean, it can be a lot more complicated. You can keep on adding functions
Okay.
on the chart and
yeah,
actually make a self-driving car.
okay,
But for the class,
oh, I see.
you don't have to go quite so deep.
Okay.
Unless you
Okay.
want.
Okay, cool. Thank you.
Okay, that's a good question. All right, give me two more classes, John.
Like real life objects.
Or something that will be modeled into a class successfully.
Okay.
Makes sense.
A news article, like on a blog or something, right? Like I assume that those
Okay.
are objects inside of a program at some
I can
point.
see how this could be. Could you give us some instance variables and methods of the news article?
Like the title, the body of the article, the author,
Okay,
the URL.
all right. And how about methods?
Could it be length? Like the length of the article?
That's
that could be a
Or is that
variable.
also-
That's also an instance
okay.
variable because it's a noun. So
Yeah.
it's
Oh,
called a
okay.
noun.
I can imagine you might want to publish or hide or delete an
That's
article.
one thing.
Yeah.
Publish a date, maybe toggle and all.
Yeah.
All right, that's a good one. I'll give you one more. So there are also many objects that are part of predefined in various computer languages. A fairly common object is the date object. So if you have a date, the date is going to have instance variables such as hour,
Okay.
hour, minute, and second, for example. And then what you can do is you can set date, get date, change date, and so on. So that's just one more example. And most languages have a date object that they work with. And let's go on before we look at the slides. Let's take a look at graphics.py if I have it here to take a look at the classes defined in graphics. And now they should make more sense because we now talked about classes. I just don't know if I have it here. Yes, I do. Great. All right, so there is a lot here. So what I'll do is just find class, the word class. There were many, so let's see what's useful here. Let's find the class that we worked with. So what is this here? So the graphics classes start here. There is a nice comment. And there is the Grasswind class. And you can see they start with the same constructor that we just learned about, except it takes many more arguments and it's more complex. And we set our instance variables, just they do as we did. And then here come the functions that are part of the Graphwind class. It's a class top level window for displaying graphics. And of course, it's a lot more complex and they have a lot more functionality. Transform, graphics object. And here's the point. Maybe this is a good one too. So we use the point, right? And it takes a graphics object. It has a constructor with self and x and y, which are the two coordinates. And then you set those values, and then they're the functions that you get. We get to call them after we import this library. Here you can move, clone, and so on. And rectangle. But you can look through this through the graphics library some more. But I think hopefully it's helpful to see how we are applying the same rules to create our own classes, even though they might be simpler. All right. Okay. All right. All right. So do you appreciate how defining new classes provides structure for complex programs? Are we now able to read and write class definitions in Python? Yes, we are. We just did. And we didn't really talk about encapsulation yet. Encapsulation is another core object-oriented concept, and it has to do with the concept of hiding data. And I'll talk more about it, but the idea is that you only show the data that you need to show, right? Because data is special and you don't want to just give access to everyone to the data, rather you want to encapsulate the data and provide indirect ways for interacting with the data, as for example, we didn't just call the description and set it, we create a method around it and set it indirectly. So talk more about encapsulation in a bit. And we're now able to write programs with simple class definitions. We know how to write interactive graphics programs, and we will work some more on this. So we'll definitely have another session on classes, at least one more. All right, and so to step back also, we have developed techniques for structuring the computations in the program. What are we doing when we are working with classes now? Are we still structuring the computation, or is it something else? What do you think? Well, it turns out that we are structuring the data. So the class structures the data of the program. Right? And data is becoming more and more important. It used to be a lot more about computations, but with big data, the algorithms are not quite as important as having the data, and then you can just let your algorithms run and compute. I mean, they're important as well, but data is becoming more and more important. Okay? So the circle is an example of a predefined class. And this is a pretty good definition if you start wondering what was that object, what's going on. You can come back to the following. An object knows stuff and can do stuff. If you remember those two things, you'll be okay and you'll be able to recreate. So an object can know stuff and it can do stuff. It knows the name of the cat, the age of the cat, and it can meow and purr and so on. But the formal definition is an object is going to consist of a collection of related information and a set of operations that are going to manipulate that information. And that's exactly what we've been doing with our shape example. And now we know the information is stored inside instance variables. We call those methods. The operations, rather, which outside of a class, what do we call these operations? Can you ask this question? What do we call operation outside of the class? What do you think? When we calculate the area, if we did it outside of a class, what would we call? Say again? It's okay. It's the word I'm looking for is a function. So outside of the class we call it a function. Inside the class we call it a method. Right? And you'll see this in other languages as well. So the methods that live inside the functions that live inside the class we call them method. Instance variables can also be called attributes. Sometimes you hear them called as properties. So you can pick your term. I guess I'll just stick with instance variables. But attributes might be also used. Okay. Do we need to go over this again, or are we okay? I feel like
Yeah, just in case.
just in case. Okay. So if we have a circle object, first of all, where is the definition of the circle object coming from?
The library.
It's coming from the graphics library. There's a class there called circle that is going to give us the definition. And then we create an instance of a circle object. It is going to give a center and a radius, and these are going to be the instance variables. They store data about, they know stuff about the circle. And then the draw method is going to use the center and the radius to draw the circle. And then the move method can change the value to new position. And then again, when we create an object, we can create multiple objects. We refer to them as instances of the class. And then the class of the object is going to determine what characteristics or attributes or instance variables the object can have. So if we created an instance of a circle, it's going to have the radius, for example, and the center, right? So it's constrained in this way. That's what makes it also powerful. You can't just define it to be anything. It can only be defined to be the right kind of data about the object in question. If it's helpful, you can think of a class as a description. I like to think of it as a blueprint. Do you have any other word that you might find helpful? Template is used sometimes. Blueprint is my favorite. All right, and now we know that when we have a new object, we have to create them by using a constructor. And then if you have a constructor, it constructs objects, so you can think of the class as a factory for stamping out new instances. And then when you when you write this line, behind the scenes, the constructor is involved. So you don't see that, but that's what happens behind the scenes. So this is the instance of the circle is my circle. And once we store the instance in a variable, then we start referring to the properties and methods or instance variables and methods of the circle by my circle dot. We use the dot notation, such as my circle dot draw, my circle dot move, because they're now concrete and now we have specific thing we want to draw or move to a specific coordinate. All right, so I don't want to do the cannonball today. All right, do we have energy for one more example together? I think we have time, and if we don't, we'll save it and resume next week. All right, so the other example I wanted to do was the student. Let's see here. All right. So the first thing you need to do, and follow this because otherwise your program will not work, please go into week 9 modules, chapter 10. And I would like you to download the students.dat file. Reminder, you need to sign in to Google to be able to download. So students.dat and then download it. All right. And then move it in the same folder where you will be working on your project. I just work from the desktop, so I'm just going to put it there. So if we look inside the students.dat, and this is a data file, so I'm opening it with Notepad++. Some applications might not open it. Notepad++ opens it, and we see here that we have a list of students, and then some GPAs and some other score information about them. Right. So we'll be working with this file. And I really don't think we'll finish this tonight. But let's start on it. So let's start a new file. Save it as gpa.py. Make sure you save it in the same folder as the students.dat file. All right. So this program is going to find the student with the highest GPA. I think what we're going to do is define our student class, and then we're going to stop for tonight, save your work, and when we come back on after Thanksgiving, we're going to finish the program and see how we can use the student class and even get information, get data from this file. So the class, the name of the class is student. And then initialize the constructor here. It's going to take, always you have to take self, and then name, hours, and Q points. So these are some points that will be in the data file. And you'll be used by now probably. We just have to set self.name is equal to name, self.hours to hours. And sorry, let's, I would like to convert float hours to a, cast them to a float, and also cast the Q points to float.
Should we float with the hours in parentheses?
Yes. Yes. Thank you. You're keeping me on my toes. Getting you to. That's not an excuse. All right. In fact, everyone should consider this error, not just John, right? All right. And then we are going to define get name. And we're going to return self.name. Now, one confusion that often happens with the get and set is that the set variable sets the value. The get one actually returns it to the program. So you get used to it, but sometimes I find students confused about it. Then we're also going to get the hours and return self.hours. Points. solve the Q points. And then the GPA is going to be the Q points divided by the hours. This is just in this particular example, the GPA gets calculated hourly. So it gives us an opportunity to use the different instance variables. So this is the definition of our class. So I'd like you to please, we'll have a little more time. Just go ahead and save your class definition. And we're going to make sure to have this for next time so we can finish the example. And until the end of the class, what I would suggest for you to do is, in week 9, I posted a tutorial that I loosely based the example that we went with the shape is based on this tutorial. It's sort of the same, but a little different. So you might benefit to read over the tutorial as well and see if you can connect. It's called Beginner Python Tutorial Classes, and it's posted under week 9 modules. So that's one activity until the end of class, or you can just, it's a lot of time now to work on whatever you need to work on. All right. Or, but happy Thanksgiving, everyone.
I'll run home for you next class.